You've memorized 47 Git commands. You use 6. Git has 160 plus built in, but your entire workflow runs on commit, push, pull, branch, merge, and the panic button, reset. The other 154? Filler. But those 6 hide a secret. When you commit, Git isn't saving your file. It's taking a snapshot of your whole project, compressing it into a 40-character fingerprint, and linking it to every snapshot before it. You're not tracking changes. You're building a time machine. Start with the one you use most, Git commit. Think of it like a Polaroid camera. You're not editing the album. You're taking a new picture of the entire room, every file, frozen in time. Git doesn't care what changed. It just says, here's what everything looks like right now, and files it away. Each snapshot gets a unique 40-character hash, A3F2C9, basically a fingerprint. No two snapshots ever share one. That's how Git knows which version is which. But that snapshot's still on your camera. That's Git push. Think of GitHub as a shared photo album in the cloud. Push mails your Polaroids there so your team can see them. And you're not sending the actual files. You're sending the snapshot data, compressed, over HTTPS. It's like sending a recipe instead of a cake. Smaller, faster, and if someone already has the ingredients, you don't resend them. What if your teammate pushed while you were working? That's Git pull. You check the shared album and download the new Polaroids you don't have. Pull does 2 things. It fetches the new snapshots, then merges them with yours. Photographed different rooms? Git combines them, no problem. But if you both photographed the same room and moved the couch to different spots, that's a merge conflict. Git says, you decide which one wins. Here's where it gets wild. Git branch is a parallel universe. You're saying, I want to rearrange the furniture, but not in the main room yet. Git copies your snapshot timeline and lets you work in that alternate reality. The main branch keeps humming along with no idea. You can take 10 new Polaroids in your branch, experiment freely, break things, and main stays untouched. Isolated experimentation, 0 risk. Now you want those changes back in the main timeline. That's Git merge. Think of it like overlaying 2 albums. Git finds the common ancestor, the last photo both branches shared, and works out what changed in each. If the changes don't overlap, it auto-merges into a new combined snapshot. But if you both moved the same couch, merge conflict again. Git can't read your mind. You pick which version stays. Conflicts aren't errors. They're Git refusing to guess. Now the panic button. Git reset. You committed a snapshot, looked at it, and thought, that's garbage. Reset is your rewind, and it has 3 modes. Soft. Undo the commit, but keep your changes staged. Just retake the photo. Mixed. Undo the commit and unstage. Rearrange before you shoot. Hard. Burn the Polaroid and revert the room to the last good snapshot. That last one is destructive. You lose work. But sometimes you need the nuclear option. So that's it. 6 commands. Commit snapshots, push mails, pull syncs, branch forks a timeline, merge combines them, reset rewinds. Everything else rebase, cherry pick, stash, is just a variation on these 6. But here's what we skipped. What is that 40-character fingerprint? Every commit hash comes from SHA-1, an algorithm that takes your files, your folder structure, your message, even the timestamp, and spits out that code. Change one letter anywhere? Completely different hash. That's how Git detects tampering and corruption. But here's the problem. SHA-1 is broken. Google cracked it in 2017. So what happens when your entire history depends on a compromised algorithm? That's next.